Hello, this is part three of practice problem factoring. So let's just continue. It says factoring completely, do not solve. So let's look at what we have. We have 3p squared plus 2p minus 5, right? And we got to factor this. And what is so special about this? There's exactly three terms. The power is 2, but the a value is no longer 1. The a value is 3, which is technically greater than 1, right? So what method will you use? You will use bottoms up factoring, or we call it AC method. It's the same thing. First step for bottoms up is rewrite as if 3 doesn't exist. So it's going to be p squared, uh, p squared plus 2p, and then you multiply 3 by the last term, which is negative 15. Okay, and then from here we just do regular simple factoring. So here's p, and then we need two numbers that are multiply negative 15, and when added gives you 2. I do believe that's possible, right? It's 5 and 3, and I'll use negative 3. Because, yeah, plus 5 and negative 3. Then with bottoms up, remember this 3 here, you're going to divide the 5 by 3, divide the negative 3 by 3. So 5 over 3 is a fraction that cannot be reduced. So what you're going to do is bring the 3 in front of the p. So it's 3p plus 5. Negative 3 over 3 can be simplified as just p minus 1. Okay, this is the most factored it can be. You don't have to solve for it. So this is the answer. Okay, let's move on to the next problem. Example 2, we have 8a squared plus 40ab plus 50b squared. So we have exactly three terms. And it looks, maybe we could do bottoms up because the excuse me. It looks like we could try doing bottoms up, but we can we take out a GCF? Well, let's start with the letters. We have I don't think we could take out any letters. Excuse me. But I think we could take out a constant, right? What could we take out? We could take out, is everything divisible by 8? Let me check. How about, well, not 8, how about 4? How about 2? Yes, I think you can only be, everything could be divided by 2. No letters can be taken out. So this would be 4a squared plus 20ab plus 25b squared, right? Right? You cannot, that's it. Could we now, is this inside the most factored can be? No, right? We could try bottoms up factoring. So let's try it. So it's going to be a squared plus 20ab. Then you multiply 4 by the last term, which is 100 b squared, and then just factor. So this is going to be a, and then what two numbers will multiply 100, and when added gives you 20, it would be 10. But we want to b squared, so we have to do the 10b, right? And then divide this 10b by 4 because we are doing bottoms up. So this is going to be a, and then 10 divided by 2 is 5. 4 divided by 2 is 2. This is a plus 5b over 2. And then also don't forget about this 2. And then 5b over 2 is a fraction that cannot be reduced. So what you're going to do is put the 2 in front of the a. So that's 2a plus 5b. Same thing here. Put the 2 in front of a. So that's 2a plus 5b. And that's it. Or you could also, what could else you have done? Since this is a repeat, you can rewrite this as 2 parentheses 2a plus 5b parentheses square. Okay. Good. Any questions? I mean, yeah, that's it for number 12. Let's move on to example 13. We have, so on number example 13, we have 5x cubed plus 40x. So there's two terms, there's a plus in the middle, so we can't really do simple factoring or even bottoms up because our power is 3, right? So it wouldn't have worked. But so what could we do? Could we take out a GCF? I believe so. We can take this has 3 x's, this has 1 x, so you could take out exactly 1 x and then do the constant. What can you take out? I believe you could take out a 5, right? There, 5 and 40 are both divisible by 5. So this is going to be x squared plus 8. And x squared plus 8 cannot be factored, right? It cannot be broken down, so that's it. So that's our final answer. Okay, let's move on. Example 14, there was an error on example 14. It should not be n squared plus 64 because that will not be factored at all. It's actually supposed to be meant as n squared minus 64. So this is the correct problem. Okay, so how do you factor this? Well, there's two terms and there's a minus in the middle, so you're most likely going to do perfect square. So if you recall, perfect square is a squared minus b squared equals a plus b times a minus b. So what you do is we have the left side, now we have to make it look at the right, make it look like the right. So we got to figure out our a value and our b value. So what do you think our a value is going to be? Yes, it's just going to be n because n when squared gives you n squared, right? And what do you think your b value is going to be? Meaning what number when squared gives you 64? Yes, 8. So once you know your a and your b, just put it like the right side of the problem. So it's going to be n plus 8 times n minus 8. And that's it. Okay, let's move on to example 15. In this example, we have 2n squared plus 3n minus 1. So how we're going to factor this is, what method shall we use? There's 3 terms, the highest power is 2, and the a value is 2, meaning it's greater than 1. So we'll have to use bottoms up factoring. First step is rewrite as if the 2 doesn't exist, so it would be n squared plus 3n. Then you multiply 2 by the last term, which is negative 2. Okay, and then from here, just do simple factoring. So this is n, and then what two numbers multiply negative 2, and when added gives you 3? That would be positive 3, right? So you need a negative 2 and a negative 1. And then what you're going to do is, remember the 2 here? You're going to divide the negative 2 by 2, divide the negative 1 by 2. So this is going to be -2/2, that's -1. -1/2 is a fraction that cannot be reduced, so you're going to put the 2 in front of the n, so that's 2n, and then leave the numerator alone. And that's it. Okay, so yeah, I think this is it. This is part 3. I'll do the last and final part, part 4. Okay.